Well, this setup has some advantages and some disadvantages. It says into the light, yes, very close, very tasty. But it should do for chemistry. Yeah, it should do. So, today we're continuing to look at small molecules of importance. We've looked at a number of really important small molecules. The last one we looked at obviously was sugar. Before that we looked at ATP, adenosine triphosphate. Now, lucky us, we are looking at amino acids. So amino acids are a very basic, conceptually speaking, molecule that happens to be incredibly important for life. There's a whole bunch of them. For example, if I were to draw you a glycine, which is a type of amino acid, its ion would look like this. There's hydrogen. We've got 3 of them, probably in some sort of surrounding configuration. We have these 2 oxygens together here, in this case with negative ion on them, a hydrogen over here and a hydrogen over here. These guys over here and this nitrate over here are all quite important. This is what essentially defines it as an amino acid. In fact, the amino section of it should make a hint at amine, and amine, it just means that there's the presence of nitrogen, which we obviously have right there. The COOH here is also an indicator of something very special. This is an indicator of something called a carboxylic acid. Whoa, crazy. So this is where the acid section of the amino acids come from. That's not why they're famous and important to us, though. What's weird is that they're so simple and cool. Why they're famous and important is because amino acids are the basic building blocks of proteins. Which means that functionally speaking, your DNA and the DNA of all other living things codes for particular amino acids. And we'll find out how this can possibly be true a little later on. It's very cool. Now, there's only 22 vital amino acids of hundreds that could potentially exist. And these are the ones that we use selectively to build all the different sorts of structures that our bodies possibly can build. Essentially, our chemical machinery only has quite a limited arsenal for it to draw upon in order to make all this wonderful stuff called you. Yeah, how cool is that? So, in order to understand how this all comes together, we've got to start talking a little bit about monomers. So, amino acids are monomers that are put together into polymers called proteins. Amino acids are monomers which are put together into polymers called proteins. This is the basic conceit of life, in a way, is it makes a bunch of these simple repeating units over and over and over again, and then the different order in which these things come into play causes them to emerge into different shapes and have different structures and different functions, and that's the great panoply and variety of existence in life that you see when you look around you, when you go into nature today. Pretty cool. All comes down to 22 amino acids being oriented at different in different orders. It's kind of crazy that level of complexity exists. So, amino acids are super important. Another ridiculously important subsection of simple molecule is the fatty acids. Fatty acids. So, fatty acids, we most often just call them fats. Fats are special because they basically hold onto a large amount of energy in a very simple form, in a very easy to access form. And for some things, this can be really good. For some things, this can be really bad. Some organisms and creatures can use fats very easily. Some cannot. You'll notice that larger scale organisms typically really enjoy fats, whereas lower scale organisms typically don't like fats, but that can be kind of a simplification. So let's not worry too much about that right now. I can give you an example of a fatty acid. This is myristic acid. It is another carboxylic acid, which means we can recognize it by its COOH or its COOH ending. Really cool and simple. I'm pretty sure I know exactly what's at the end of this, but you're a little too big on my document. Disappeared forever. Perfect. So, this is rather a chunky acid, but here we'll go for it. So first we have our most important section here in terms of the carboxylic. This is the carboxylic acid functional group, right? We talked a little bit about functional groups before. Functional groups are basically the special characteristics of carbon backbones that make them their thing, as opposed to just some other random molecule. There's dominant functional groups. We don't want to get too much into that, but basically as an atom gets more complicated, as an organic atom gets more complicated, basically it has more functional groups interacting in more and more peculiar ways. There you go. It's the basics of it. So this guy's a letter card. What did I... 4. You know what? I'm going to do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, from here, things are actually quite simple. So, while I'm putting hydrogens on the outside of these carbons, let's talk for a moment about why I'm putting hydrogens on the outside of these carbons. What's really going on with each of these carbon atoms is that they have these kind of shells of electrons that are dancing around them in sort of time probability space. It's crazy, but it's true. And these electrons that move around the atoms are what give them their actual properties. And carbon is special because it has all sorts of different overlapping potential orbitals in ways that the vast majority of other elements on the periodic table do not. In fact, carbon is special because it basically allows for 4 external connections of considerable strength. So we are allowed to build up these complicated molecules that have all of these crazy different properties, but we also have a relative level of stability inside of our bodies and as mechanisms. As the atom gets larger and larger, there's different potentials. The actual physical size of the atom matters because that changes how the probability wells of the electron fields around the atom function. Yeah, this is more of a physics kind of thing, though, so we'll talk about that a little more later on. So this is a basic fatty acid. Again, here you can start to see how this might be constructed. How might this be constructed out of monomers? Well, apart from this beginning section and this end section, this CHH connection, if we just repeat that like 12 times, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times. Did I do this wrong? Whatever. If I repeat this 13 times, then I get this entire central section of this molecule. This is the essential concept of a monomer, and this is the essential structural idea that your body's going to use in relationship to DNA in order to construct all of the different crazy parts of stuff that are you. I got more to talk about with chemistry. Come back, we'll do a part 2, where we'll dive into bonds, because this thing's held together by bonds. What are bonds? They're overlapping orbital electron shells. But they have a bunch of weird characteristics, and sometimes they're not even quite as simple as that, maybe. Have a great day. We'll talk again soon.